Perfect. Hello, everyone. I'm excited to talk to you today about AI coding. For today's presentation, I'll try to make it as hands-on as possible, and I'll make sure that I'll show you like some live demos of like how you could apply all of the concepts that I'll be talking about today. And in the end, I'll have a sample app on GitHub, so I'll give you a link to it so that you can, if you'd like to adopt any of those configurations, you'll see all of those configured within that app. Before we start, I thought I would start by identifying like what do I mean by AI coding and what AI coding is, or to be more precise, like what AI coding isn't. So what I don't mean by AI coding, I don't mean vibe coding. So I don't mean the few prompts that you can give to like a Replit or a Lovable and you would get like an app on the other side. I'm talking about like when you're actually coding with AI. And like when you're involved in architectural decisions and like you're reviewing the code that is coming out of like the AI agents that you're using. So I'm not talking about prototyping. I'm not talking about like the tools that your designer could be using when they are like using V0 or Figma Make to come up with like some prototypes. I'm talking about like actual code that you would ship into production. I'll be walking you through my favorite setup and like the tools that I use whenever I'm using any of those tools. But before we get into this, like, can we have like a quick show of hands of like, did anyone try any of those tools? I'm expecting most of you did. Okay, can you leave your hands up like if you're still using it to this day as your main IDE? Okay, so that is very common, by the way. So it seems that like the majority of you have tried it, but like you're not using it on a daily basis till now. In fact, there was like a recent survey done for like one of the biggest mobile communities, and their feedback was actually very similar to that. I captured a couple of the comments in here. So you will see that like something like the first comment, for example, that says that like it still struggles with new frameworks of mobile development, which makes sense. Like a lot of those models, they didn't have any of the new frameworks or of the new languages specifically for mobile in its training data. So it doesn't make like it makes sense that like it's not as accurate for the mobile technologies versus the web and backend technologies. Or things like the second or third comments that like it still struggles with certain functional or non-functional requirements that are mobile specific, things like battery consumption or like app launches or things like that. Or with like UI responsiveness and like the specific UI paradigms that are mobile specific. My favorite comment is the last one in here, that it is pretty annoying having to go back and forth between whatever tool that you're using and Android Studio whenever you want to test or run on an emulator or whenever you're running on a device. But then the funniest comment was this one. We all have that person on our team, the AI skeptic, the 10x engineer that is too smart to use AI. But when you get to look at like those comments and that feedback, you will see that it actually makes sense. Like the problem is most AI coding agents are built for web and backend workflows. It doesn't understand mobile as well, and it doesn't integrate with mobile tooling, which kind of breaks the definition of what an AI agent is. So one of the abstractions of what an AI agent is this diagram on the right, which is like basically it is an infinite loop of an LLM call and a tool call. And like the LLM call takes in the prompt, decides which tools to use, then it calls that tool and takes that input as an input for the next LLM call. The problem is that once we break that loop, once we have like a person that needs to sit in the middle and needs to translate whatever that came out of the tool to the next LLM call, once we start to have like a manual input in there, that kind of breaks the whole flow, and you end up using a fancy, overpriced tab autocomplete. The opportunity that I want to talk to you today is what if we connected our mobile environment to the agent so that it can build, test, and fix issues directly. And those are my goals for today. So one, I would love to convince you by the end of this talk that you can actually start to use those tools as like the main driver for mobile development. And two, that like you don't need to keep switching between whatever tool that you're using and Android Studio. And three is that like once you do that, you will be able to use it for more than tab autocomplete. And fourth, like I would love to give some shout outs to some of the tools that I used and I really liked. A bit about me. So I'm the co-founder and CTO here at a company called Lusic. We're a team of 250 employees. We have like one of the biggest mobile teams in the company. And we work with companies of like all of the different shapes and sizes. So starting from like a small 10-person AI startup to like the big enterprises like T-Mobile, Verizon, Porsche, and like the bigger companies. I've been a mobile developer for more than 15 years. That next one is like an iOS joke, like for you who have ever used to develop pre-Arc. So Arc is automated reference counting. Before iOS 5, you had to manually increment and decrement reference counting for the garbage collector to work. For those of you who are developing on Android, you were too spoiled. You didn't have to deal with those issues. But like we used to spend hours debugging those kind of issues. But thankfully, now I'm coding mostly with AI full time. For today's talk, I'll be splitting it into like the 3 phases of the software development lifecycle. So starting with development, then testing, and I'll be closing with observability. So starting with development, how you can provide the right context to those models and agents at the right time. Then in testing, how we can close the loop of like the build and test feedback. And observability, how we can automate as much as possible of the maintenance lifecycle. So starting with development. First one is that you just need to decide like what tools you're going to use. There is like the IDEs that you could use from and like the models that you could be using from. I personally use Claude Code with Sonnet 4.5 and Opus 4.1 interchangeably. I think like everyone is going to have their own opinion about this. I'm not here to talk about like the different approaches and like which models to use. I think you could pick, like you're probably going to get like very similar results as long as you're using any of the state-of-the-art models. So like feel free to pick like whatever that you would like from those IDEs and models. What actually matters most about like the quality of the output that you're going to get is the context that you're going to give those models. Which brings me to the second point, which is the rule files. So as we're saying, like those models are not trained on the mobile specific context. So we need to make sure that we are feeding those models that context. So things like how you build your app, how you test your app, how you like if you're using any new frameworks or if you're talking to any APIs, whether it's like your backend APIs or third-party APIs, you need to make sure that you're including those in the context for your models so that it knows what code it will be generating. And like there are different ways of doing that. Like you could be just like linking to those documentation if it's public documentation, or you could be actually including them within your project. And I'll show you a couple of demos of like how you could do that. Third thing is that slash commands, and like whenever you find yourself doing any repeated task, it's always easier for you to create a slash command for it. And it could be like the simple things like slash test, slash run, slash commit, or it could be like the more complicated ones, like writing a test case or debugging a ticket. All of those are like steps that you would normally do sequentially, and like by just like creating those slash commands, it makes your life much easier. And I'll show you a couple of demos of that as well. But that's like the first step of like providing the context for your models or your agents while in development. The next step is on the testing phase. So on the testing phase, like the main goal that we want to get to is that we want to close the loop for building and testing feedback. And like the first step of it is the build and how to build the app and how to run the tests. So for that, like you could be using the Gradle MCP or the Gradle CLI. There is also a lot of opinions about like MCPs versus CLIs, and like there's a lot of like opinions and preferences about this. I personally use CLIs. I find them to be more context efficient, but you could also get a very similar output if you're using the Gradle MCP. There is like an open source one that you could just like refer to here, or you could just use the Gradle CLI and make sure that you are steering the model towards using the CLI in the way that you wanted to use it. And I'll show you a couple of demos of like how you could do that. Second step is running on the emulator. So like now you've built the app, you made sure that your tests are passing, now you want to run it on an emulator. And there are a couple of MCPs that you could use for that. There is one by a company called Minitap, and there is another one by a company called Mobile Next. The strength of those MCPs is that it allows you to run an emulator, install the app on the emulator, launch the app on the emulator, then it can actually interact with the app. So for example, if you're developing a feature and you want to validate that the feature is working, you will be able to use that MCP to navigate through the app and make sure that it is doing the expected behavior that you're expecting. It can also take screenshots. So it can take a screenshot to make sure that like whatever the feature that you were expecting actually was actually as you were expecting it in the same visual way that you were expecting it. One interesting feature that they're also adding is that they're adding an integration with Figma MCP. So in that case, they can take a screenshot and compare it to your Figma file to make sure that it is like a pixel perfect output compared to what you were expected to get out of the feature that you're building. Now that you've tested on your emulator, and if you want to test next on like an actual device, you could use BrowserStack for that. BrowserStack, they recently launched an MCP that also allows you to do all of that from within your IDE. So you don't need to leave whatever IDE that you're using. You built, like you did the code change, you built the app, you made sure that it is running correctly on the emulator, then you made sure that it is running on an actual device. Let me show you a demo of what that would look like. Okay, so this is a sample app that I've built, and like this is Cloud Code running on Sonnet 4.5. Let's assume that like I want to create a new do a change in this app, and I want to change that text from "Hello World" to say "Hello droidcon London." So I'll put it into plan mode here, and I'll paste that command for it here. What this does, plan mode, what it does is that it starts first by exploring the code base, making sure that it understands it understands the project architecture and like the structure of the app. Then it starts to understand like the feature and like the prompt that you gave it, and it comes up with a plan. It then confirms with you that this plan is what you were expecting. Then it starts to execute it. So it says here that how would you like the Android logo implemented? Vector drawable, submit. Now it's coming up with the plan. It seems that it already understood like what the structure of the app is, and now this is the plan. So it's going to change the string, it's going to draw the logo, then update the layout. Okay, this looks good. I'll tell it to start to implement and to auto-accept. While this is working, let me just like show you the project structure that I have here. That is too small probably, right? Okay. So this is the CloudMD file that I have. So we'll see here that I've first started with like, this is the tech stack that I'm building my app based on. This definitely helps it a lot when it comes to like any configuration that it needs whenever it's running the app. Then this is the project structure. If it's a complicated app, you definitely don't need to include every single file. You just need to give it like an idea of like what the structure of your app looks like. Then I have the commands for how to build the app, how to run the tests, how to do a clean build. Then you will see that there are a couple of best practices here, for example, that I'm linking to, like any developer documentation that I would like to link to. In this app, I also wanted to include a couple of examples of new APIs. So for example, assuming that I'm doing screen recording detection, this is something that was relatively recently added in Android 15. And I wanted to make sure that like the model is aware of like that API and how it works. So what I did is that you will see here in the docs, I have here like the full the full documentation that you have from Android documentation. I've included it here, and I'm referencing it here from the CloudMD. So whenever I ask it to implement anything related to screen recording, it always refers to that documentation. Or if it's like a third-party API. So for example, like if I'm building like a Twitter or an X Twitter client and I wanted to communicate with its API, for some reason their API documentation blocks any AI agent that isn't Grok. So like I needed to include that in my documentation. So you will see here that I included all of the endpoints that I need for building that app. I included all of the endpoints here, all of the inputs, all of the responses. I included all of that here, and then in the CloudMD, I'm just referencing it here as like the API integration. Let me check on how it is going. Okay, it seems that it is done. Before we review the results, let me just like show you like a couple of other commands, the slash commands that I have. So you'll see here that I have like the slash build command. It includes like all of the details of like how to build the app. and how to validate that the build is successful, including like making sure that the APK is created. I have another one here that is called like /emulator. This launched the emulator, and I have like the steps of how to do that. Then there is another one called /device. This is the one that communicates with browser stack through the browser stack MCP. It launches on like a specific device, and it does like the steps that I'm expecting it to do. And like there is like the rest of like the commands here. Like there is a couple of ones for managing Git, and I have like one for debugging a crash and one for debugging a normal issue. Let me go back to here. Okay, so it seems that it did the change. Now let's try to run it on /emulator. So /emulator, this is going to break it down to like a few steps. So it starts by building the app, then installing it on the emulator, then launching the app, and confirming that the change was actually done. Of course, this is all probabilistic, and like we're doing a live demo, so like if that's screwed up, I'm sorry about this. Looks like it's working. So it is built the app, launched, installed the APK on the emulator. Now it's launching the app, and here you go. It changed the text, and it added the Android logo. Now it's taking the screenshot to confirm that the screenshot is actually what it was expecting based on the prompt that we gave it. Now assume that like we don't only want to test it on an emulator, we also want to run it on a device. So in that case, I'll just call the /device command. This is the one that communicates with browser stack. So it goes through the same steps. It builds the APK first, then it launches the device on browser stack. It starts a new session with the specification that I gave it, and then it installs the app and it launches it. Network seems to be a bit slow. So now it launched the device, downloaded the app, installed it. Then it's running now on the device. So like all of this, like without leaving the IDE that I'm using. So like within the IDE, I'm getting able to validate the whole workflow. Okay, perfect. Let me go back to the presentation. Okay. So that was the first two phases, like the development phase and the testing phase. Let's go to like the third phase, which is the observability phase. Of course, like issues are not only going to happen when you're testing in like your local environment, it's also going to happen when you're in production. And like for that, like this is what our product specializes in, which is production monitoring, starting from like the bugs to crashes to performance issues. So anything that like that your app might be encountering in production, will be capturing that, and like you will be able to see it on our dashboard. But the recent thing that we added is our MCP server that brings also all of those issues and like all of those details into your IDE, so that you can look into them, look into the issues that you're seeing, start to analyze them, and starts to work on a fix for them, all within your IDE. Let me show you a demo of what that looks like. Okay, so I'll go back here. I only have like the URL of the crash, and that's it. So I have created this / command called debug crash. What it does is that it takes in this URL. It then takes the URL, parses it out into its components, then calls the Lucid MCP to get the details of that crash. Then it works on analyzing all of the details that it gets from the Lucid MCP to come up with the root cause of it, and then start to suggest a solution for it, all within the same IDE that you're using. So it started here, it captured the details from the URL, and you will see here that this is the crash summary, this is the root cause of the crash, this is the affected code, and those are the options that you could be following for fixing that crash. And like it could be as simple as like you can now say, let's go with option 1, for example. And like in that case, like it's going to start to execute the fixes for that crash, all without, again, like leaving your ID. Now let's go back to the deck. Okay, perfect. So this is the first step of getting alerted whenever there is an issue that happens. Like one of the other investments that we've been doing is, what if you would like to use background agents for automating that maintenance workflow? So starting from the detection of an issue to the analysis and figuring out the root cause, to creating the fix, to validating it and rolling it out. Like we now offer you that you can automate that whole maintenance workflow. And the way that this works is like parts of it is probabilistic using AI, but we also made sure that we have guardrails around like the probabilistic part of it that is very deterministic. So for example, like whenever we detect an issue, we analyze it and like we generate a fix that we think should be fixing that crash, but then we have to run it through your CI. So in that case, we validate that the app is still building, like it didn't break any of the unit tests or the tests that you have. And then we start to do a gradual rollout. So we integrate with the app stores to make sure that we're doing a gradual rollout starting with 1%. And when we roll it out to 1%, we make sure that this crash that we started to solve was actually solved and it didn't regress and it didn't cause any other new crashes. So we make sure that this is the case before we start to ramp it up from like 1% to 5% to 10% to 50% and then eventually to 100%. But of course, we also give you the option if you would like to be involved in that loop. So in that case, you can be confirming whenever any of those steps are done. It can confirm with you before it progresses to the next one. So for example, it will be suggesting to you the root cause, and it will be confirming with you that like, do you agree that this is the root cause or not? And then it starts to generate the fix, and it confirms us with you that like, is that the fix that you were expecting or not? So you can decide like how much involvement do you expect to be within that loop. But like a big part of that loop is very repeatable in a way that you don't need to be doing it manually. Like a lot of it can actually be automated. So we've covered now like the 3 phases, like the development phase, the testing phase, and the observability phase. I thought I would just like leave you with like a quick recap. So where should you start? So the TLDR is that like those tools can now work for mobile. It just needs some time for you to configure them and make sure that they are working as you were expecting. So the first one is providing the right context at the right time, making sure that it understands the structure of your project. And if there is any extra details that you want to give it that is mobile specific, make sure that you're including it within the project structure and you're referring it in the context whenever you're prompting the model to do any actions. The second one is closing the loop and making sure that it can generate the feedback that it needs, starting from like the build phase to like the testing and like running on devices, and making sure that it is actually able to capture that feedback back to be able to iterate on the generation of like the fix that it is working on. Third is automating as much as possible of the maintenance loop, starting from detection to fixing to rollout. Fourth point, and I think that this is very important for the team adoption, is the source control as much of the configuration as possible. So making sure that like the nth team member on your team that is going to start to use this is not going to start from scratch. Like they're going to start with like some configuration that is already source controlled within your application. This definitely makes it much easier for the rest of the team to start to adopt it and to have like broader adoption within your team. And finally, like to expect that this is going to take some time and effort, but it's totally worth it. Like once you start to invest some time in it, like you will start to see some results. And for that person on your team, you will just need to convince them that like it's going to be a bit slower at the beginning, but hopefully like it will be faster after you get used to it. Finally, I wanted to leave you with this sample app. So like this should show you like a sample app with like all of the configurations that I was talking about today. And if you'd like to know more about the topic and to keep up to date, those are a few people that are talking consistently about these topics specifically for mobile. You will see that like there is a lot of people that are talking about like AI and all of that, specifically for web and backend technologies. But like there is definitely a few that are actually talking about integrating those into mobile. That's it. If you guys have like any questions, please, I can take some questions now, or if you'd like to see a demo of any of the things that I talked about, or if you'd like to see a demo of like the rest of the Lucid product, we have our booth outside, so feel free to drop by our booth at any time. Thank you.